Aloha and welcome. In this video, we're going to be talking about software-defined networking. We're going to start off with a discussion of infrastructure as code, and this is something that's a little bit different from what you're used to. Normally, you have things like routers and switches, pieces of equipment that take physical connections. If you're going to be working on it, like for example, I'll pull up a switch here, and a switch looks something like this. So it's a standard device. If you want to, if this, let's say this switch was actually managed, we could go in here into an interface. We could modify different aspects of it. We could define port bonding and things like that, where we're combining bandwidths and setting all kinds of settings in here. That is the way we traditionally have managed physical networks. Now we're introducing this concept called infrastructure as code. And this is where you're going to be managing and provisioning computer data centers through machine readable definition files instead of hardware configuration or interactive configuration tools. So we're going to be doing this declaratively, which is kind of like you can use menus to, pick and choose kind of what you want, but we're looking at defining the desired state. And the desired state is an IAC feature that declares an infrastructure's final or desired state instead of actually configuring it, by the traditional step-by-step approach, defining the routes and things like that. So an example they give here is Amazon Web Services has something called Cloud Formation that works as its IAC, infrastructure as code. There's a good example in the book too of in the participation activities that shows you this. Um, we continue in this with an overlay network explanation. And overlay networks, they're a type of IAC. And these the overlay network, it's a virtual network abstraction layer built on top of the existing physical network infrastructure. So many of the modern networks leverage at least one overlay network technology to improve the network performance without an additional investment in network equipment. So software-defined networking, SDN, that's an overlay network technology that centralizes a network's management and control planes. So centralization allows for more granular traffic management and efficient resource allocation. It enables administrators to dynamically adjust to changing network conditions and demands. Additionally, SDN facilitates the rapid deployment and management of virtualized network functions, enhancing the network flexibility and scalability. So we're talking about using SDN to define more broadly what our network is to do. So when we look at our devices and we're defining them individually, when we're looking at software defined networking, what we're talking about is an abstraction of it to try to see, okay, how do we want to best, route things in here? What is the end game? So you're using definitions to define this. So we take that a step further with the software defined wide area network and SD-WAN. You've seen a lot of this on the tests that we've had, and SD-WAN's finally refining the definition for it. So SD-WAN, software-defined wide area network, that's taking this idea of the software-defined network and bringing it out to multi-location facilities. So by the book, they define it as a software-defined network, centralizing a multi-location networks management and control planes. So you've got three planes when you're talking about networking. You've got the control plane, you've got the data plane, you've got the management plane. So the way you think about that is the control plane is the network plane that determines how the packet is going to be transmitted, from place to place. The data plane is the actual network plane that transmits the packet. Then you've got the management plane, and that's the network plane that manages the nodes, the different devices on that on the network. So going back to what we're saying, SD-WAN enhances secure communication by embedding security features such as encryption, intrusion protection systems, and firewalls directly into the network's architecture. So such an integration facilitates the enforcement of consistent and automated security policies throughout all locations. So we're not talking about just our one little location. We're talking about taking a larger one. So the WAN, stands for wide area network. So we're talking about much wider than just our little LAN or local area network. So we're centralizing the management of it, but we're defining the behavior of the entire wide area network itself. And there's a good participation activity for you to go through online that will show you a little bit about that. Um, Next, actually last, we have software-defined visibility and a discussion of APIs. So software tools that monitor network traffic on the cloud as well as on-premise networks. That's essentially what we're talking about here. Software-defined visibility, SDV, refers to technologies enabling network traffic visibility to any monitoring device, regardless of the device's physical location on the network. So that's good. So cloud-based application typically uses APIs to integrate with other applications and microservices. We've talked about APIs. APIs are application programming interfaces. They allow you to get information out of systems that are running applications that are running. So let's say you've got something like an accounting program or something. You can have an API call to it to pull out little bits of data, things that you need. Of course, you want to have secure communication going back and forth. You want to authenticate to it and make sure that not anybody willy-nilly can go and connect to that and get data out of there because that's probably sensitive data. So you want to be able to check those things. So API calls should be inspected to prevent an attacker from sending malformed data in an application API. So many SDV solutions provide visibility into API calls to SDN components, assess the cloud applications for vulnerabilities, and detect features deviating from best practices. That's where it can really save you. So if you've got APIs that aren't following best practices and are allowing, let's say, people to pull information they shouldn't, the SDVs are used to detect this. And an example they give is Microsoft Cloud App Security is a tool that evaluates various aspects of a cloud application, including the application's account permissions, auditing, and data scanning. So SDVs are important to do these functions. They make sure that your APIs are secure. And that is pretty much it for this quick chapter. Remember, we're talking about software-defined networking. We're talking about networking that is defined through, uh, definition files. We're not going to be talking about the direct, you know, connecting to your network using an emulator and then going in and changing different things inside here. You're not having to, you're not having to physically do that on one device. We're talking about defining the desired state for it. And then when we abstract out, and we're going to be talking, we talked about overlay networks and looking at the behaviors that you want from the network as a whole. So you have that abstraction layer that goes above the physical, that you have there to try to define what, you want going on there. So you can define the best routes, and you want it to be responsive. So when we take that and we abstract that out to a multi-location scenario with a wide area network, we talk about software-defined wide area networks, and it talks about how we're securing the networks your network planes, and you've got three different network planes that we talked about here: control, data, and management. And then finally, we followed up with discussion of software-defined visibility and APIs. So you want your SDV, your software-defined visibility software to look into your APIs on the network and make sure that they're locked down, that they're not leaking out information, and that they're following best practices. So that's it for this section. If you have any questions, feel free to reach out. Aloha.